Hello class 6. We'll continue chapter number 3 again, that is force. Alright, we are in the different types of force. We discussed all about the different types of forces in the last session. Today we'll do weight. Today we'll do this weight. Okay, W-E-I-G-H-T, weight. Alright, so this weight is in fact the gravitational pull of the earth on an object. Okay, actually it is the gravitational pull of the earth on an object. Okay, the gravitational pull of the earth on an object actually is the weight. Okay, in other words, the force with which the object is pulled downwards towards the center of the earth, that force of the earth itself is in fact the weight of that object. Okay, so it can also be expressed this way. Weight, W means weight, M into G. Okay, weight equals M into G. That means weight means in fact the mass of an object into acceleration due to gravity. Here with the differences between this weight and mass. Weight is the force, but mass actually is the quantity of the matter contained in an object, which we have discussed in other session also. Okay, in the class that we have discussed what mass actually is. It is a quantity of matter contained in an object. So suppose let us say my weight. What is my weight? Means the matter contained in my body into the force of gravity. Okay, the force of gravity, that means the pulling force of the earth with which I am pulled towards the center of the earth. So that total, that product of my mass and the gravity of the earth in fact is the weight. But whereas mass, as I have told you, is the quantity of matter contained in an object. Okay, that is mass. So mass always remains the same everywhere, but weight gets differed from place to place. You see, for example, weight of an object varies from place to place. Suppose let us say I am here on the earth. So the weight of my body will be different from the weight of my body if I am taken to the surface of the moon, because the gravity of the earth and the moon is not same. Okay, so it depends upon the gravity of the earth. So that is weight. But whereas mass remains the same. The size of my body will remain the same even on the surface of the moon. That means that is mass. But here we are talking about weight. Weight actually is the force of gravity of the earth with which it is pulled downwards towards the center of the earth. That is weight. So here for your standard, this definition would be appropriate. Let us see. The gravitational pull of the earth on an object. That itself is weight. Okay. So weight is measured with the help of this device, which is called spring balance. Okay, spring balance is a device with which the weight of an object is measured. Alright, so this is the diagram of the spring balance. You must have seen it. Okay, you must have seen it there in the markets also when you go to the vendors to buy some things. So there, when you have to measure the weight of something, you must have seen using this kind of device, which is called a spring balance. Here the spring is used out here. Here is the pointer, and here are the different readings coming from 0, 1, 2, 3, 4 downwards. Okay, like that up to 10. It is shown in your book also. so that I always suggest you to see your book also. Keep your book open so that you can go simultaneously through the video as well as through your book. Okay, then here is a point, here is a pointer, and here is a hook. Here is a hook with which the object to be weighed is, is fixed, it's hung. All right. Suppose this is to be measured. Its weight is to be measured. So this way, this object is hooked out here, and it is fixed somewhere else in the support. Then when it is hooked out here, then it will pull down. Okay. When it's pulled down, then this pointer will be coming down wherever it is fixed. This pointer wherever is fixed, so that will be the reading of the weight of that object. So this is how the spring balance is used in measuring the weight of an object. Now we have another subtopic, that is aiding forces or resultant force. Okay, resultant force. A single force formed of two or more forces acting on an object together or conjointly is called resultant force. Okay, let me write it once. A single force formed of two or more forces acting on an object conjointly is called resultant force. See, I have written here a single force formed of two or more forces acting on an object conjointly, which means together, is called resultant force. Okay, sometimes the case becomes like this, where we see a number of forces from different sources act on an object together. Okay, and it gives, or it results into a single effect. Okay, or it gives a single resultant force at the end because of the combination of all those forces together. So that force itself, that single force itself, is called resultant force. All right. For example, you see, let us say something has to be lifted. Okay, or one object is there. Suppose object one, load is there. This load has to be, suppose, shifted a little far. It's to be, shifted somewhere. All right. Suppose a person A applies, let us say, 50 Newton of force. Okay. To lift that load, a person, let us say A, applies 50 Newton. Okay. Then another person B applies 50 Newton. He also applies 50 Newton to that object. Okay, in the same direction. So the resultant force will be 50 Newton plus 50 Newton will be 100 Newton. See. So 50 Newton plus 50 Newton, another 50 Newton. 50 Newton of the force applied by A and 50 Newton of the force applied by B will be together here, will be, joined, will be summed up, and it becomes 100 Newton to this object, to this load, so that the load can be shifted. So this single force formed of the combination of these two forces together is called resultant force. But Another case also sometimes, may be there. The forces which you see there on an object may not be in the same direction. Sometimes those forces may be, acting on an object in the different directions or in the opposite direction also. So in that case, what will be the resultant force? Let us see now. Suppose this is the object. This is the object. Suppose this load. Okay. So A applies from here, from this direction. Suppose 100 Newton. 100 Newton. So what is Newton here? We had discussed before also there. So Newton means the unit of force. What is that? The SI unit of force. So 100 Newton of force, suppose, is being applied by A in this direction. So in the opposite direction, another person, let us say B, applies 70 Newton. Okay, in these two different or in these opposite directions, these two are applying the force on the same object. So what will be the resultant force out here? See, in this case, the resultant force will be the difference of these two forces. Okay, that is difference will be A minus B. That is 100 Newton minus 70 Newton, which means 30 Newton. So this is your resultant force. Alright. Now we'll see frictional force. Though we discussed frictional force in the last session, let me tell you something more about it, because we need to talk about the advantages and disadvantages of frictional force as well. So here we'll see the definition of frictional force once again, and also the characteristics it has. Alright. Okay. Frictional force is the force formed between the surfaces of the objects in contact. Okay, the force which is formed in between the surfaces of the objects in contact. So it is an example of contact force, because there are mainly two types of forces which I have discussed before, that is contact force and non-contact force. So it comes under the contact force. Okay, the force which is formed between the two surfaces of the objects in contact, that is the frictional force. Alright, so the main characteristics of frictional force are as follows. Number one, it depends on the smoothness or roughness of the surfaces in contact. Okay, number one characteristic of frictional force is this: it depends on the smoothness or roughness of the surfaces in contact. That means the surfaces where this frictional force is being caused, is being produced, okay, is very much important for it to see the magnitude of the frictional force. If the surface is smooth, okay, if the surface is smooth, if the surface in which it is being produced is smooth, the frictional force will be very less. Okay, frictional force will be less. And if the surfaces are rough, the frictional force will be more, which means smoother the surface, the lesser is the frictional force. Similarly, rougher the surface, more the frictional force takes place there or is produced. Okay, number one. Number two, another number two important characteristic of frictional force is this, that it always opposes the motion of one body over another body. Okay, it always opposes. Okay, it always opposes the motion of one body. It always opposes the motion of one body over another body. Over another body. See? It always opposes the motion of one body over another body. See, suppose, because two surfaces means out here the two objects. Okay? So, here always the surface of this body will oppose the motion of this object, and the surface of this object will oppose the motion of this another body. Okay, so that way they oppose each other. Alright, so this way, these two important characteristics of frictional force we need to understand as per our standard. There are some other also, but these two are important for you, so you can understand it also. Alright, there are some more which are very much difficult for you to understand. That's why let us not do that. We just stick to these two characteristics of frictional force. Alright, then another important thing that I want to tell you about friction or frictional force is that frictional force, see this frictional force, it is a necessary evil. See now, it is a necessary evil. Evil means something bad, in fact we know. Okay, but it is very important. That means this frictional force has both advantages and disadvantages. In some cases, we want to reduce the frictional force for our benefit. In some cases, we want to increase the frictional force as per our need. That means we need this also in some cases. In some cases, we don't need. Okay, for example, let us say your frictional force formed between the sole of your shoes and the surface of the ground or the way on which you walk. See, yeah. If there is no frictional force between these two surfaces, then anytime you may fall off. You will slip and fall off. Okay, that chance is there. You cannot walk only. Alright. Yes, so because of the frictional force between the two surfaces here, the sole of your shoes and the surfaces of the ground on which you are walking, because of the frictional force between these two only, you are able to walk. But what also happens there is that wear and tear of your sole of your shoes also takes place there. That means on one way it is helping you, in the other way it is cursing you also by wearing and tearing your sole of your shoes. Okay, so here we find both advantages and disadvantages. So from that point of view, your friction or frictional force is a necessary evil. Okay, today we'll do this much. Please go through the video and try to understand it. Alright, thank you very much.